Another special problem is before us. Please read and follow the question carefully. A curve passes through 2, 0. And the slope of the tangent at the point xy is x plus 1 whole square plus y minus 3 by x plus 1. What can you grasp from that? It is just nothing but dy by dx, isn't it? Slope of the tangent at xy is dy by dx. Then the area bounded by the curve on x-axis is such some large sentences and bulkier appearance is there for the problem. But you see, there are two things required. Number one, dy by dx is equal to this, you take it. That is a differential equation. You may have to solve it. There will be an arbitrary constant c that must be obtained by using the point 2, 0. A curve will be obtained. Area bounded by that curve and x-axis is the main question. So, this is a combination of differentiation, differential equations and areas of plane curves. Yes, that is why I like to call it a special problem. Okay, what is it actually? Slope of the tangent at any point xy. And shall I call it dy by dx? Of course. Therefore, dy by dx is therefore equal to x plus 1 plus y minus 3 by x plus 1. Well, my dear, this looks somewhat bulkier. You may use a small technique. What is that technique? Put x plus 1 is equal to capital X, y minus 3 is equal to capital Y. Come on, dear, what is d small x? D capital X, d small y, d capital Y. Therefore, d capital Y by d capital X is equal to capital X plus capital Y by capital X. How slim it is. It is simple. Bring that y by x this side. Dy by dx minus 1 by x into y is equal to x. It is linear in y. Therefore, if is equal to e power integral p dx. What is p here? Minus 1 by x. Minus 1 by x dx. What is the integral of minus 1 by x? Minus log x. E power minus log x. And minus log x is nothing but log 1 by x. Thus is nothing but 1 by x. Therefore, if is equal to 1 by x. Come on, friend. If is obtained. Now, what is the solution? Therefore, solution is y into if. Y into 1 by x is equal to integral of q. What is q? Capital X. What is if? 1 by x dx. dx. X and x will go away, leaving you only 1. Therefore, y by x is equal to, this is nothing but 1. Integral of 1 is x plus c. Therefore, y is equal to x square plus cx. What is capital Y? Y minus 3, isn't it? Y minus 3 is equal to x plus 1 whole square plus c into x plus 1. That is the ultimate solution. And it is not impossible, or rather it is not difficult at all. For explaining only, I could have done all these steps. But you can minimize the steps by proceeding in a speedy way. It is not impossible to arrive at that conclusion of the general solution. Now, what are the things before us to do? Number one, we have to get C. How to get C? It has been given that the curve passes through 2, 0, isn't it? So, by substituting 2, 0, you can have See, but 2, 0 lies on this. Substitute. Y is 0, minus 3 is equal to 2 plus 1 is 3, 3 square is 9, 3 plus 1 is 4 plus 4c. Good. 4c is equal to minus 12, hence c is minus 3. Therefore, c is equal to minus 3. One particular aspect is completed. We could have got the solution completely. What is the solution? Y minus 3 is equal to x plus 1 whole square minus 3 into x plus 1. The only thing that has remained here is to find the area bounded by the curve and x-axis. Well, but 2, 0 lies on this curve. So, 0 minus 3 is equal to 2 plus 1 whole square is 9, 2 plus 1 is 3, it is 3c. 3c is equal to minus 12, hence c is equal to minus 4. c is equal to minus 4. Therefore, the curve is y minus 3 is equal to x plus 1 whole square minus 4 into x plus 1. Therefore, y minus 3 is equal to x square plus 2x plus 1 minus 4x minus 4. What is minus 4 plus 1? Minus 3. Minus 3 and minus 3 will go away. So, y is equal to x square minus 2x is the curve. And we know that it is a parabola which meets x-axis at 0 and 2. Like this. It meets the parabola. It is the parabola which meets x-axis at 0 and 2. The required area is this. One more thing you may have to notice, the curve lies below x-axis between 0 and 2. Therefore, the required area is integral 0 to 2 2x minus x square, because we have to take the modulus of that. As x square minus 2x is negative between these two limits, between these two limits x square minus 2x lies below x-axis, that is, it is negative. So we have to take integral 0 to 2 2x minus x square. Therefore, required area is equal to integral 0 to 2 2x minus x square dx. What is the integral of 2x for x square? So the required answer is 2 square is 4 minus 8 by 3. 3 4s are 12, 12 minus 8 is 4, hence the answer is 4 by 3, so many square units. What is the answer? 4 by 3. Another special problem. So far we could have seen linear differential equations. In this problem, linear differential inequality is there. You observe df by dx is greater than f of x he has given. How to tackle with that? Yes. How to have the solution? The answer. I have written the 4 options also. He has just asked the nature of f of x. Is it greater than 0? Is it greater than 1? Greater than e? Or greater than 1 by e? Which is more specific. We want to decide. Look here. df by dx minus f of x is greater than 0, isn't it? As df by dx minus greater than f of x, I have brought f of x this side. You don't ask me why I am multiplying this with e power minus x. df by dx minus f of x is greater than 0. Well, my dear, irrespective of the nature of x, whether it is positive or negative, e power minus x is always positive. if you multiply an inequality on both the sides with a positive number, there will be no harm to the inequality. That is why I have multiplied with u power minus x. Well, my dear, you could have got the idea. How do you get the idea of multiplying with e power minus x? You just observe up to this part. This is nothing but LHS of a linear equation, isn't it? What is p? Minus 1. What is if? E power integral minus 1 dx is nothing but e power minus x. Okay. Why do you multiply that? The very purpose of if is multiplying that. Multiplying the equation with that, so that the given equation can be converted to exact form, isn't it? Okay, you can see one thing. This is nothing but d by dx of e power minus x into f of x is greater than 0. Is greater than 0, isn't it? Okay. You observe it. U dash e power minus x into f of x minus 1 into plus e power minus x into df by dx. Surely, you name this particular part as some g of x in your mind. This is the derivative of g of x greater than 0. What can you say about that? By the conditions of monotonicity, this particular function is increasing, isn't it? E power minus x into f of x is increasing, monotonically increasing. Well, if you take 1, e power minus 1 and f of 1 is 0. Okay. Therefore, x greater than 1 implies f of x greater than 1. It is strictly increasing. Which is the increasing function here? E power minus x into f of x is increasing. Therefore, x greater than 1 implies e power minus x into f of x is greater than e power minus 1 into f of 1. But f of 1 is 0, implies e power minus x into f of x is greater than 0. But you see, e power minus x is absolutely a positive number. So, if you can divide or multiply with e power x on both sides, so you have f of x is greater than 0. First option is the right option. So, here, this is the problem in which linear differential equations and monotonicity both are involved. Both are involved. That is why we can say that this is a special problem. Another special problem is approaching as, you please follow the question, the sentence given in the question. There is a curve which passes through the point 2a comma a, for which the sum of the subtangent and abscissa is equal to a. What is the equation of the curve? Here, two pieces of information has been given. The first one is it passes through the point 2a, and the next one is length of the subtangent and abscissa. The sum is a. Let the curve be y is equal to f of x. What is the formula for length of the subtangent? Y by m, isn't it? That is y by m plus abscissa is x is a, where m is equal to dy by dx. Isn't it? Therefore, y into dx by dy plus x is equal to a. Therefore, dx by dy plus 1 by y into x is equal to a by y. A by y. Isn't it? Or even you need not do all these things. Y dx plus x dy is equal to a dy. A dy. y dx plus x dy is nothing but d of xy. Therefore, integrating which we have xy is equal to ay plus c. Xy is equal to ay plus c. And we want to know c. How to get this c? But this passes through a comma 2a. Therefore, a into 2a is equal to a into 2a plus c. Isn't it? Therefore, a into 2a is equal to a into 2a plus c. So that c is equal to 0. Hence the curve is xy minus ay is equal to 0, or y into x minus y is equal to 0 is the curve. Another beautiful problem is waiting for us. The tangent at any point P on the curve meets y-axis at n, and M is the foot of perpendicular from P on x-axis. If the area of triangle OMN is 1, then the curve is. First of all, let us have the equation of the tangent. Let y is equal to f of x be the curve. What is the equation of the tangent? Let P is equal to x1, y1. Tangent is y minus y1 is equal to m into x minus x1, where m is equal to dy by dx at x1, y1. At x1, y1. Isn't it? This meets the curve. This meets y-axis at. You put x equal to 0. What happens? 0. What is y? What is the value of y? Come on. 0. You made 0, 0. Minus mx1. y1 minus mx1. Also, what is, this is n. Also, m is, what is m? Foot of the perpendicular from P. What is P? x1, y1. x1 from x1, y1. You draw the foot of the perpendicular onto x-axis. Then what is m? Automatically it is x1 comma 0. x1 comma 0. Now, you understand, try to understand the curve, the triangle. This is x1 comma 0. This is x1 comma 0. And this is 0 comma y1 minus mx1. He has asked us, he has given that area, this area is 1. We are to make use of that concept. But area of the triangle OMN is 1. What is the area? Half into base into height y1 minus mx1 is 1. That is, now I would like to use the general coordinates. Instead of x1, y1, I like to use xy, isn't it? Then x into y minus x dy by dx is equal to 2. Y minus x dy by dx is equal to 2. Implies y minus x dy by dx is equal to 2 by x. 2 by x. Implies y by x minus dy by dx is equal to 2 by x square. 2 by x square. Or dy by dx minus 1 by x into y is equal to minus 2 by x square. Again, this is linear in y. You look at the problem. It has been given in terms of tangent, some subtangent, in equation of the tangent, area of the triangle, etc. It belongs to applications of derivatives. And the essence is now thrown into differential equations, that to a linear equation. What is the integrating factor here? Integrating factor is equal to e power integral minus 1 by x dx. For 1 by x it is log x. For minus 1 by x it is minus log x. Minus log x is nothing but log 1 by x. So it is equal to e power log 1 by x. Hence e is nothing but 1 by x. Well done. Solution is y into integrating factor is equal to integral of minus 2 by x square into 1 by x dx. It is minus 2 by x cube. You bring minus 2 out. What is 1 by x? What is 1 by x cube? Integral of 1 by x cube is minus 1 by 2x square, isn't it? So this is minus 2 into minus 1 by 2x square. So that 2 and 2 will be cancelled. Y by x is equal to 1 by x square plus c. 1 by x square plus c. 1 by x square plus c. So if you multiply with x square, you have xy is equal to x plus cx square. That is the curve. That is the curve. And he has not given any information about c, so we cannot find c. You stop there itself.